Hello everyone, I am Abhishek Datta and you all are watching my YouTube channel Mathematics Made Easy. Today I am here to discuss about a very important topic under set theory known as relations, that is set relations. Now students often get confused between set relations and set functions. These are two very similar concepts but having some fundamental differences among them. So first I shall discuss set relations, and in my later video we shall discuss about set functions, because set functions are nothing but some particular kind of relations only with some restrictions imposed on them. So let me first discuss the concept of set relations. Now before going deep into this concept, students must have some basic idea about the cross product or Cartesian product between two sets. So let me take you to my note application. So here let us start with the concept of cross product of two sets. Often also known as Cartesian product between the sets. So this is a very important concept which everyone must understand if they want to grasp a detailed concept on set relations. So what we mean by cross product of two sets, this is simply to multiply two sets. So for example, let us consider a set, say capital A, having members A, B and C, and also another set capital B having the numbers 1 and 2. Now if we are to form the Cartesian product or cross product between the two sets A and B, this is symbolically denoted by A cross B, as we normally use the multiplication symbol like that, A cross B or A into B. So this is equal to the set A, B, C multiplied by the set containing the elements 1, 2. Now how to form the cross product or how to multiply these two sets? The resultant is another set of ordered pairs. So here what we have, the result is a set of ordered pairs. So ordered pair means we have to pair the elements of the first set, that is A, with the elements of the second set in all possible manner. How to do so? We fixed one member of the first set. Say if I fixed the element A of the first set as our first member, then we associate A individually with each and every member of the second set in ordered pair form. So likewise, the first pair becomes A, 1, that is the member A of the first set is associated with the member 1 of the second set, and again the member A of the first set is now associated with the member 2 of the second set. Similarly, we associate the member B of the first set with each of the two members of the second set. So B is also associated with 1 and again with 2, which gives us the next ordered pairs as B1 and B2. And finally, we associate the third member C with each of the two elements of the second set, which gives us the ordered pairs C1 and C2. So finally, this set defines the cross product or Cartesian product between the sets A and B. So as we notice here that the elements are in pair form, but in each pair the abscissa, that is the first member, belongs always to the first set, and the second member always belongs to the second set. Similarly, if we are to define the product B cross A now, that is, we just reverse the order. So this will be the set 1, 2 multiplied with the set A, B, C. So likewise, we shall get another set of ordered pairs given by 1A, 1B, 1C, and similarly 2A, 2B, and 2C. Always be careful that the members of the first set should occur at the first place, and the members of the second set must occur at the second place in each ordered pairs. So clearly, as you can see, A cross B is not equal to B cross A. These two are usually different from each other because the pair A1 is not same as the pair 1A. Similarly, the pair A2 is not same as the pair 2A. So in general, Cartesian product of sets, this operation is not commutative in general. Commutative means if A into B becomes equal to B into A, we call them commutative. In general, we have Cartesian product of A and B is not equal to Cartesian product of B by A. So this is the concept of cross product or Cartesian product of two sets. Let me now proceed to the concept of set relations. Here we are dealing with the same sets A and B. So our set A has the members A, B, and C. The set B has the members 1 and 2. Now a relation between these two sets A and B, defined by the symbol R from A to B. This is the statement. R is said to be a relation from the set A to the set B. The set A, that is the first set, is often referred to be the domain set of the relation, and the set B, that is the second set, is referred as the co-domain set of the relation. So A here is the domain set and B is the co-domain set. Now basically, what is R? R is nothing but a subset of the Cartesian product of A and B. So basically, R is a subset of A cross B, which means any subset of A cross B defines a relation from the set A to the set B. And as you all know, by subset we mean a portion. So likewise, if I choose a portion of A cross B, this is our A cross B set. So let us choose some particular pairs. Likewise, as I have already highlighted, A1, A2 and B2. Let us choose these three particular pairs from A cross B. So this forms another set, say R1 consists of these three particular pairs A1, A2, B2. So that is our set R1. The set of ordered pairs A1 and A2 and B2. So this is a particular subset of A cross B. So here R1 defines a relation from A to B. R1 is said to be a relation from the first set A to the second set B. And how to diagrammatically represent this relation? So we draw the respective sets here, A and B. Here is the set A, which is domain, set B as the codomain. Here are the members A, B, C, and the respective member of the set B, that is 1 and 2. So the relation R1, what it does, it relates some elements of set A with some elements of set B. As we can see here, that A is related with 1, A is also related to 2, and again B is related to 2. So this is the diagrammatic representation of the relation R1 from the set A to the set B. So basically, by a set relation, what we mean that some or all elements of the first set, in this case the set A, are associated or mapped to some or all elements of the second set, that is the set B. As we can see here, some elements of A, that is C, is not associated with any members of B. Only the two members A and B are being associated with the elements of the set B. Similarly, we can have another relation between the same two sets A and B defined by R2. We can choose another relation R2. Simply we have to choose another subset of A cross B. So if I now choose another subset of A cross B, these are the three initial pairs A1, A2 and B2, these pairs we chose earlier. Now let us choose some different pairs marked by green, say B1, C1 and C2. Let us choose these three pairs B1, C1 and C2. So the set R2 contains the ordered pairs B1, C1 and C2. So what is the diagrammatic representation here? Again we have the respective sets A and B. These are the members of A, these are the members of B. Now here, as we can see, that A has no association at all with any member of B. As the set R2 defines, A has no association with any of the member of the set B, whereas B is associated with 1 and C is associated to both the elements 1 and 2. So this defines the second relation R2 between the same sets A and B. So basically, whenever we choose a subset of A cross B, what we are doing, we are mapping or corresponding some elements of the first set with some elements of the second set. If I consider another example now, R3, say, which contains A1, B2 and C2, and if I, so this is clearly another subset of A cross B, and if I go for the diagram, so here we have the respective sets, and here the association is as follows: A is associated with 1, B with 2 and C also with 2. So as you can see here, that here all members of the first set are mapped or associated with all members of the second set. So basically, relation between two sets is to associate or pair some or all members of the domain set, which is the first set, to some or all members of the codomain set, that is the second set. Likewise, here we have associated all members of the first set with all members of the second set, whereas in the previous example some members are associated, only this portion of A takes part in the association with the entire set B. The element A does not take any part. Likewise, in the previous example, only the elements A and B are associated with the entire set B. So whenever we discuss about set relations, it is simply a relation or association between two sets A and B, whereas some or all members of the first set, which is also the domain set, is mapped or associated with some or all members of the second set, which is also known as the codomain set. Hence, by set relation, we can now establish a definition of set relation by saying that a relation from the set A to the set B is defined as a subset of A cross B. So this is the fundamental concept of set relations. So basically it is a subset of A cross B. So any subset of A cross B defines a relation from the set A to the set B. The next question which arises, that how many such subsets are possible. So we know that if a set, say capital P, has n number of elements, that is, if cardinality of the set P is say m, that is the cardinality. Cardinality means the number of elements which a set contains. If it is m, then we can have 2 to the power m number of subsets of the set P. So this will be the number of subsets of the set P. Therefore, as A cross B, or we can say cardinality of A cross B is same as the cardinality of A multiplied by the cardinality of B. As we can see earlier that our set A, NA, consists of 3 members ABC. So cardinality of the set A is 3, and the set B consists 2 members 1, 2. So cardinality of B is 2. And as you can see that there are 6 elements in A cross B, that is A1, A2, A3, A1, A2, B1, B2, C1, C2. So we have 6 members in A cross B. So hence the cardinality of A cross B is same as cardinality of A multiplied by cardinality of B. So therefore, in total we can have 2 to the power NA times NB number of subsets of A cross B, as we defined earlier, that since cardinality of A cross B is NA into NB, so we have 2 to the power cardinality of A cross B. So many subsets of A cross B we can have, as we defined here, that if a set P has cardinality M, then we have 2 to the power M number of subsets of the set P. That means the number of subsets which can be formed from a particular set is given by the formula 2 to the power cardinality of that particular set. So here in total we can have 2 to the power NA times NB number of subsets. In this particular example, this becomes 2 to the power 3 into 2, which is equal to 2 to the power 6 number of subsets of A cross B, that is, which stands up to be 64 subsets of A cross B. So as we have defined 3 of them, R1, R2, R3, similarly this list can be extended up to R64. So we can totally have 64 number of relations between these two particular sets as discussed in this example A and B. So basically by set relations, thus what we mean is to form the Cartesian product or cross product of the sets and then choose any subset of that cross product, and that particular subset will define a relation between the first set to the second set. So this is the basic concept about set relations. In my next video, I shall discuss some more concepts about the set relation, some particular types of set relations and some examples of them. I hope this video is helpful to you. If you like my video, please subscribe to my channel. That will help my channel to grow. Thank you all.